Whoa, and welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you once again from the Smash News Network, least busted name in news. Thanks for tuning in. Welcome to Space. Congratulations on realizing the channel exists, etc., etc. We do have a new sunspot. The story is Filaments. Let's get to it. Well-defined coronal hole down here in the south. It is of south polarity also. So starting out with filaments, here's a filament family dance happening up in the northwestern crown region, what we would call a crown prominence, just a type of filament that's hanging off of the edge of the solar disk from Earth's perspective, and a great Earth scale there for comparison. The size of that largest filament there, several Earth diameters in size, at least the part of it that we can see from the SDO. Continuing on, we're going to go all the way around the horn. Again, the story is filaments. We've seen a drop in solar activity, and remember, folks, you don't need to see sunspots or solar flares even to see coronal mass ejections. NOAA's forecasting one to strike Earth later today. I'm not so sure about it, but we'll keep an eye on it. And when I say ion, well, pardon the pun. By the way, pardon the flashing and the odd motion there in the SDO. It looks like the instrument rolled there, and the aspect was adjusted as that occurred. Apparently, some sort of a roll maneuver by the SDO. It looks like only one instrument. You won't see that same roll maneuver in the magnetogram. Great coronal hole down here, as well as a fairly well-defined one here north of these active regions. Here is your southwestern limb. And again, a new sunspot did just indeed rise. It just came into view in the past less than an hour ago, right here. I think it's a revisit of an old sunspot, and it is quite large, at least as far as I can so far tell. Here's the eastern equatorial region. Again, more South Pole-oriented coronal holes here coming into view, becoming more well-defined, and I have a feeling there's a lot of plasma in between the Earth and Sun at the moment. Closing out these views, here is the northeastern limb, and let's take a close-up of this gigantic filament. By the way, if you want to name filaments, links below the video in the description to our Twitter feed, our Twitter profile. Make sure you follow the hashtag #NameThatFilament. That would be a good one to name. And somebody named this one after a cosmologist. Again, if you want to follow up on that, if you want to name filaments after living people, join us over on Twitter, hashtag #NameThatFilament. Here's the closest star in SDO intensitygram, and things have been pretty stable here over the past 24 hours. No major changes happening there in those sunspot groups. Again, a new one just rose in the southeast. You'll see the field barely coming into view perhaps there. We'll show you some high-res imagery of that before our meteorology segment. And let's talk volcanoes. Cotopaxi doing some outgassing there. Great image of Cotopaxi. Let's see what else is erupting today. And by the way, happy Hitler's birthday. Not sure why everybody's so stoked about the birthday of Der Führer. Der Führer. Anyway, some explosive activity happening at Mount Ibu, producing a 6,000-foot plume of volcanic ash. As Ibu explodes, also Semeru exploding, 15,000-foot ash plume there over East Java, flight level 150, flight level 070 over Dacono. Popocatépetl exploding, flight level 210 over central Mexico. It's a 21,000-foot plume of volcanic ash. Popocatépetl is on my bucket list. Also Fuego, mildly exploding, sporadic emissions of volcanic ash over Guatemala from Fuego. Nevado de Ruiz in Colombia producing a 24,000-foot plume of volcanic ash. As it explodes, it's a flight level 240, flight level 200 over Ecuador from Sangay, flight level, who knows, over Cotopaxi, also in Ecuador. The column heights between 6.7 and 7 kilometers of altitude there. Also, a flux of SO2 sulfur dioxide emissions, which reached 51 tons on April 18th. Also, Sabancaya exploding in Peru, producing a 25,000-foot plume of volcanic ash. And No matter how bad things look, please do not pole vault the caldera. Because a quick reminder, folks, our finest days lie ahead. So if you're concerned that things couldn't possibly get any worse, they can get a lot worse. And in some ways, they perhaps shall. However, things will bounce back again. This too shall pass, like we said in the year 2020. We just didn't really expect it to take over 3 years to pass. Anyway, in any case, there's a light at the end of the tunnel. Do not pole vault the caldera is our top seller. Links below the video to our Redbubble shop. And let's take a look at global seismicity. Next, there's the past 90 days, and the largest quake happened just before we streamed this video. We'll get to it here. It was a 5.5 off the coast of Central and South America. So we'll run up the list here. Here are the quakes from the past 24. There was a 5.0 at Indonesia. That was at 14:06 yesterday, Universal Time. 5.0 at Indonesia. 5.1 at just south of Kamchatka there, it looks like. That 5.1 was at 1916 Universal Time yesterday evening. Quakes continue at California. None of a large magnitude. We'll cite quakes over a 5. And there's the largest quake of the past 24. It occurred at 10:55 this morning on 4/20. That was a 5.5 off the coast of Central and South America. And let's get back to space. So we've got some more spectacular imagery, and let's do a cosmic ray report, as we haven't done one for a while. And by the way, the 10.7 centimeter radio flux is now at 147. So it's dropped down again since yesterday. No surprise there, as a bunch of sunspots have set. And let's take a look at cosmic rays. So first we'll go to Apatity and Barentsburg. And at Apatity, we've had an uptick in cosmic ray flux over the past 30 days, as you can see from that graph right there. And at Barentsburg, also a slight uptick, almost flat at Barentsburg, but a tiny uptick. Next we'll go to Athens, Greece, which, by the way, Athens has a great neutron monitor database that you can access from their website. And Athens has got a bunch of missing data, although over the past 30 days, a tiny uptick there. That looks legit, although that missing data, that's just missing data. Anyway, Mexico City showing a minor uptick over the past 30 days. And let's go to Oulu, Finland, and Antarctica. So a little uptick at Oulu over the past 30 days. DOMB Antarctica, slight uptick. And DOMC Antarctica, a similar graph, a slight uptick. So the past 30 days of cosmic ray flux on planet Earth featured a slight uptick. So that's a little bit of energy from space news for you. We do cosmic ray reports on the channel like once a week at least. And let's take a look at the 1-year graph of the 10.7 centimeter radio flux here, getting back to solar data. The 10.7 centimeter radio flux represented by the black line. The red line is the sunspot number. Perhaps you can see how proportional those are. The radio flux and the sunspot number, they are directly proportional variables showing solar activity. Anyway, again, the radio flux now at 147 solar flux units. NOAA is forecasting a mild geomagnetic storm late today, Universal Time. Perhaps, hey, we're hoping that it happens, because I'd like to see some aurora. I sort of doubt that we're going to see anything there, but hey, possible CME impact late tonight, or actually starting around midday Universal Time. So any moment we could actually see a coronal mass ejection impact, as according to NOAA. So we'll be keeping an eye on that. And when I say eye on, well, once again, we're going to make the merch for you. So here's the past 4 hours of Earth's magnetic moment from space. And you can see things are pretty homogeneous here, as the plasma around Earth's magnetosphere strives to reach static equilibrium. You can see things, the pressure there reducing in the past 4 hours in Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. And if we do see a CME impact, this would be a good map to check to see if aurora are likely to be visible in your area. This will show you things like telluric currents, the likely places to see induction into power grids, railways, pipelines, etc. Earth's magnetic moment from the ground in nanotesla for the past 4 hours. And the planetary K-index, an average of global geomagnetism, is quite low here at 0.66. KP 0.66 is the current situation. And let's go to the real-time solar wind next, measured out here outside of the magnetosphere at Lagrangian 0.1. So here is the Discoverer as the current active spacecraft. Current conditions are, most current conditions are, just under 400 kilometers per second for the solar wind velocity, solar wind density, just over 7 protons per cubic centimeter. The rest of that is fairly unremarkable. However, I would note that sometimes when you don't see a real signal in the things like the density and speed of the solar wind, sometimes you'll see a signal showing up in the plasma temperature. So sometimes this green bar features some interesting factors in it. You can see some minor little upticks there in the plasma temperature happening, but things are pretty minor here at the moment, pretty slow and diffuse solar wind. If we do see a CME impact, we should see a major signal. Next, looking at the GOES magnetometer here, and we've seen some very low highs and indeed low lows over the past 24 hours. Check it out. We only got to 108 nanotesla there for the GOES 16. And now flirting with those levels once again. Again, low highs and low lows there on the GOES magnetometers. Those are measured from the GOES near equatorial geosynchronous orbits at like 23,500 miles of altitude. Next, we'll look at the heliospheric current sheet. So this is the polarity of the solar plasma. And Earth is solidly in a south pole current sheet depicted there in red. Nothing to write home about there. Let's look at our line of sight field plot. Here the sun's B field is depicted in blue, polar fields in green for north and red for south. And let's move to coronal holes next. So here's our coronal hole view. And again, we've got south pole oriented coronal holes here. And keep in mind, if you're new to the channel, you may not be aware that during the sunspot cycle, the south solar polar field needs to make it to the north by solar minimum, and vice versa for the north polar fields making it to the south. That is the definition of solar minimum, when those fields find themselves fixated back at the poles, will be at solar minimum. So that's why we show the line of sight coronal hole plot daily, because it gives us insight into the solar polar field reversal process. Here's yesterday plus today in 211 angstroms, a great wavelength to view coronal holes. And you can see quite a few coronal holes there rotating in the south, in the eastern limb. And those are going to be geo-effective within a week. This one is going to be geo-effective in only a couple days. So we can expect some major upticks here from coronal hole high-speed streams. By next week at this time, we'll probably have seen some geomagnetic storm conditions from it. So that's something to look forward to. Hopefully we'll see some aurora down here in Lehigh Valley, Pennsylvania. Next, looking at sunspots. And we've really seen a downtick in sunspots here. A few have set on the western limb. So there's the current situation. There still is a likelihood of large flares, especially from 2 spots. So the 2 most likely spots for large flares, in my opinion, would be down here where this new sunspot is rising. We're not sure the field complexity of that one. And of course, sunspot 3282, which remains huge. And to a lesser degree, these groups down here. There is some magnetic complexity, and there are lots of plasma filaments. So another quick reminder that we don't need to see flares to see coronal mass ejections. Let's take a look at sunspots here from some more SDO custom videos. There you have the 131 angstroms wavelength to show the active regions, along with the SDO continuum depicting the photosphere. The layer of the sun where sunspots occur. Here we've zoomed in a little bit on those same wavelengths. And let's drop the 131 angstroms. Now, I'm not sure if the sun is writing a message, but it seems to start with the word C and end with the word O. If you've got ideas about a message being scrawled across the sun in Sunspot Umbre lingo, let us know what you think the sun is writing. Is that a message to mankind? Is the sun telling us to listen to Miss Cleo and her psychic forecasts? Let us know what word starts with C and ends in O that the sun is interested in telling us in nice English, in nice, perhaps Arial font. All right, let's move on to energetic particles and solar flares. We ain't got no energetic particles, otherwise known as solar energetic particle events, or SEPs. It's been flatlined for a long time, and we're only seeing C-class intensifications for the past 24 hours in terms of X-ray flux. Remember, folks, don't get coronal mass ejections and solar flares confused. They're a completely different phenomenon. Solar flares are X-rays, which are like light. They're made of photons, high-frequency photons, or X-rays. Coronal mass ejections are protons. Think of a fan blowing air. Very different. Air versus light, protons versus photons. Hopefully you understand the difference, and hopefully if you're watching space weather channels that don't understand the difference, you'll correct them, as we need more people looking at space weather, not less. All right, so here's the past 24 hours in 94 angstroms from SDO. Pardon the shaking and the weird motions of the SDO. We have little control over this. And let's take a moment to look at a star chart, as we're always interested in what's going on overhead, and most of this stuff is not able to be seen now, although the sun is visible up there. Of course, the moon practically overlapping the sun here. And of course, if you're up just before dawn, you may see Jupiter heralding the sunrise there, just to the southeast of the ecliptic. Here's a solar system forecast, and happy new moon, by the way. This is where things are now for all of you Earthlings out there. And if you're viewing the video from another plane of existence, timeline, universe, galaxy, spacecraft, etc., plane of existence, let us know in the comments. Here's your 1 week forecast for heavenly bodies in the solar system. And that is where things will be on the 24th. Continuing on to coronagraphs, and we did see some CMEs yesterday. Are they earthly directed? Well, it doesn't look like it. We'll show more information to help to verify. So these are 102 frames from yesterday. Here are 25 additional frames from today. A little bit of CME activity there, also in the southeast. Also does not appear to be earthly directed. Let's take a look at Stereo A's coronagraph also while we're on the subject. We'll also show the Soho-Lasco C3, which is somewhere around here at Lagrangian 0.1. All right, so Soho-Lasco C3 on the right, Stereo A coronagraph on the left. We'll let that play through a full run. Just keep in mind these are not synced. It is 90 frames on each one, but pay attention to the time and date stamps down there at the bottom. And if we ever call it wrong, if you think we've failed to forecast a CME or incorrectly forecasted one, let us know in the comments. All right, so here are our 24-hour videos featuring SDO 193 angstroms. Some great scenic imagery there of some fireworks, not likely to be affecting people like you. Yeah, I don't believe those are even on the Earth side of the sun. Possibly coming from an area behind that new sunspot that rose in the southeast. Again, the story is filaments. And you can see a lot of those in 193 angstroms. There is a name for one of them, only the crown prominence. Here's an even better view of filaments from El Teide, Spain's ground-based solar observatory. See a little bit of activity happening up here from that large sunspot group. And look at the filaments. I mean, that is a filament fest. Let's do a quick count. So I'm seeing 1, 2, 3, 4, 5, 6, 7, at least 8 filaments. This one here is already named, the Bob Lehman filament. Again, if you want to name filaments, link in the description to our Twitter profile. Follow the hashtag #NameThatFilament. And here's a great view of filaments. This is what we usually show to highlight the filaments there. That's 304 plus 193 angstroms. Might be the most contrast for filaments there. We figured we'd kick off the video with a little different wavelength, 173 plus 211, if you want to recreate those wavelengths for your own purposes. Here's the past 24 hours in the house favorite 171 angstroms wavelength. And I would note that active region there rising in the southeast, that is a sunspot, and it's a large sunspot. And here are the past couple of hours from the GOES 16 SUVI. This is called the Andrea Ghez filament, named after the quote, discoverer of the supermassive black hole at the core of the Milky Way galaxy, end quote, the massive radio source known as Sagittarius A star. So this brings us to our bonus features segment. Charging hazards for satellites. If you want to follow it yourself, it's the Satellites Community Dashboard. And when you see major charging hazards, you can actually verify it by looking at certain satellites, like the GOES weather satellites might show you the charging with some errors at the moment, not likely to happen. Charging hazards are non-existent. The GOES electron flux here remains kind of low. I think I forecasted it yesterday. See yesterday's video for details. And there you go. We expected it to be a little bit lower than NOAA's forecast, and indeed, the yellow boxes are the observation. The yellow diamonds are the observation. The green boxes are not full of talc. The green boxes are the forecast. There's the one-year chart to put that in context. We're in a trough. We're in a bit of an electron deficit at the moment. So low electron flux here for an extended period of time, as you can see from the one-year graph from Solon.info. And let's take a look at the layer of the atmosphere where it's measured. The upper thermosphere, known as the F layer, is located at about 300 kilometers of altitude, and here is its vibrational frequency. So in some ways, this is actually an input into the Earth system. If you're one of these people who claims that all Earth weather comes from space, well, you're probably right. Of course, there are some internal workings on planet Earth that can affect things like weather and climate. I won't try to create a list here. Suffice to say that there are perhaps lots of variables that are not in certain models that ought to be in order to forecast things. Anyway, if you're not familiar with looking at that, here's the Anomaly Gram. This is the previous day, showing anomaly in megahertz from the 30-day median, and that is quite an anomaly here, stretching from the South African anomaly to the South American anomaly. So you see a low-frequency anomaly stretching right across there, right there. That is interesting indeed, as I would suspect those low-frequency anomalies are areas where we've got additional material in there. So you could actually be seeing a seeping of matter there into the Earth system. Of course, it's quite diffuse out in space, but there is a process that plasma makes its way into the planet's atmosphere eventually. And I suspect that's what you're seeing there with all those low-frequency, some of those low-frequency anomalies. as we get closer and closer to understanding the relationship between Earth weather and space weather, this may become more and more important. We keep cataloging it on the channel. Anyway, there's the latest image. That's 12:15 Universal Time Ionogram and 12:15 Universal Time Anomaly Gram. And let's take a look at the total electron content also. So this would be the free electrons all the way out to your GPS satellite, all the way down to your handset. It's a run of about 12,500 miles. And it's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Let me bring that back and let it run all the way through here. And thanks for leaving a comment, TinMan1057. Good morning to you, sir. All right, so here's our latest intensity gram and latest STO magnetogram. And the real story is going to be a new sunspot. So it is barely visible, but I can see an umbra right there. You might be able to see it. You might not be able to see it. There is the magnetic field. I suspect it is a South Pole umbra. Besides that, things are pretty inactive. So, but there is still a propensity for a large flare. If we are expecting to see a large flare, I mean, hey, this area right down here is very magnetically complex. Check it out. That is beta gamma delta class. This area over here is beta gamma delta class also. So there is a high likelihood for large flares, which continues. And of course, if you've got an idea what the sun is trying to write, let's see, what could this be? So there's a C, there's an O. What about? Is it Coolio? It could be Coolio. I don't know. That's my only guess. And let's move to meteorology. Now that we've shown you all of the space weather portions, let's zoom in a little bit closer. So I'm doing some wave chasing now. So what you're seeing there, the animation is the surface wind scenario, and the coloration is significant wave height. And the world's largest waves are currently out there pretty much in the middle of nowhere in the southern Pacific near the Southern Ocean boundary. And a close second is this area right here by the Drake Passage. Looks like a pretty bad day to be heading through the Drake Passage, as there are 27.7 foot waves down there. As you may not be aware that I am a wave enthusiast. So anyway, let's get to our regularly scheduled meteorology segment here. And these are the surface winds. Like sands through the hourglass of time, these are the surface winds of your lives. And these are the jet streams of the Eastern world. Today we'll go to the west. These are the jet streams of the Central world, that is Africa, Europe, and the Middle East. Yes, and these are the surface winds of this side of the planet, featuring the Holy Lands, Western Europe, and the cradle of mankind, perhaps. And here are the surface winds of the Americas, the West. And them, right there, these and those, are the jet streams. Next, how about a lovely cloud map? It's going to show you clouds and fog. It's 3.9 micrometer infrared radiation. If you heard me say nanometers in the past, I wasn't thinking. It's micrometers. Nanometers are like the size of an atom. And micrometers are like 1/10 the size of a human hair. That's the infrared spectrum, not X-rays. Anyway, here's your weather.gov map. And once again, if your location is lit, please head to weather.gov and click your location. We'll briefly scroll down for your convenience to show you what the key means. The hydrologic output is a bunch of melting snow causing flooding. And let's look at some forecasts. Weather.gov is the location of that, and allow me to vanish to show you the temperature anomaly forecast for the next 72 hours on the GFS model. 72-hour GFS temperature anomaly forecast is what you're seeing here. Some major melt coming to California. Here's your 72-hour GFS pressure and precipitation forecast. As a large band of snow is going to produce some severe weather, starting out in Iowa, southern Minnesota, and then a huge band all the way from Texas to Indiana. So some major severe weather coming there. Mainly around the Mississippi Valley, the southern Mississippi Valley. Be prepared for that. Next, we're on our windy.com map, and we're just looking at wind. And, man, looks like a bad day to be in the North Atlantic. DAG. So a serious low pressure system here. And what's the pressure out there? All the way down to 972 hectopascals. That's your windy.com sea level pressure map, as there is a low centered over western Iowa. Check out the lightning. Strong lightning here around places like Kansas. Repeated lightning storms there. And let's see if we have any strikes currently occurring. I suspect that we do, indeed. Northern Missouri. Kansas City, for that matter. There is thunder rolling in. It looks like a pretty minor thunder shower there in Kansas City. Anyway, there's your full globe map. Strong lightning over Eastern Europe again, according to lightningmaps.org. All right, here's our U.S. Doppler radar map. There's the full 50-state view of AUSA, former nation now Banana Republic. There is the lower 48 view. Strongest weather there right over Missouri and Iowa. Snow continues to fall in Montana. Here is clouds and fog, 3.9 micrometer radiation. Rapid cloud nucleation happening there over Oklahoma, as you can see on the water vapor map. That's 6.19 micrometer infrared radiation. And you can see this great example here of a little bit of high pressure providing an impulse as well as a pressure gradient there, driving that weather as well as pushing it up to the northeast. Because, folks, dry air is more massive than moist air because of the molecular mass of nitrogen versus water vapor. Them's the facts. Here's a recap of U.S. radar, U.S. clouds and fog, and the water vapor. So, thanks everybody for tuning in. Congratulations on realizing the channel exists. These videos were brought to you in part by the Smash Team at smashomash.com/Smash Team. If you want to be part of the operation, or if you'd like to hear a plausible mechanism underlying the solar sunspot cycles, consider becoming a gold member. If you become a gold level Smash Team member, you can also get an @smashomash.com email address and access to additional content. We created our own subscription services site back in October of 2021. The best value is the gold annual paid-up subscription. There's also a silver and a bronze level, which will cost you $0 per month. Also, happy 420 sale, as there is a sale going on the Hemp Lucid shop. Link below the video to our Hemp Lucid shop. Don't forget to enter the promo code SMASHOMASH to save some dough on checkout. Even if you miss the 420 sale, save 40% through the day today. So get your shopping done at Hemp Lucid. And if you are unable and or unwilling to help us out with some subscription services, etc., or to donate, help us out with clicks by visiting smashomash.com. Lots of links there, links to the Redbubble shop, a permanent invite link to the Discord chat, and more. So we'll see you soon. Thanks again for tuning in. If you viewed the live premiere, thanks for leaving a comment. Press like, subscribe, share. We'll see you soon at the Smash News Network least busted name in news. And may that solar wind be at your back.